So a quick little problem to illustrate something that goes wrong with a lot of people in their calculations. Let's look at the United States, and we're going to go back a couple years ago to look at the population. And about 1% of the population in the United States is 6'3" or taller. That's 6'3". But in the NBA, 75% of the NBA players are taller than 6'3". So we're going to define two events. T is the event that somebody is tall, so we got that event. And the probability of being tall, randomly picked by being that tall is, well, we'll round it up to 1 in 100. And on the flip side, we've got N is the event that somebody is picked at random that plays in the NBA. Now, in the 2018-2019 season, there was 522 players out of a population in the United States at that time of about 327 million. So a question I could ask would be, what's the probability of picking somebody at random who is 6'3" tall and plays in the NBA? In other words, I want to calculate this probability. Probability of probability of T and N. So kind of direct way. It was on one of the handouts the other day. It was an unmarked one. But I'll put a copy of this in the notes. So the point that I'm going to get to here is pretty quick and doesn't require a lot of notes. Now, if you wanted to calculate the true probability, you take 75% of the 522 players and then rounded it up to 392. 392 out of 327,000 is about 1 in 835,000. That'd be your chance of randomly picking somebody who is 6'3" or taller and played in the NBA back in that season. So that's the actual probability. Let's take a look at what I get on exams quite often. I give somebody these probabilities. Probability of being 6'3" or taller is 1 in 100. Probability of playing in the NBA is about 1 in 625,000. So what's wrong with this calculation? That the probability of N and T, which is be the probability of N times the probability of T, is the product of those two probabilities, and you get 1 over 62,500,000. Boy, that's way off, isn't it? You compare this answer to the true answer, and they're miles apart. So what went wrong with this calculation? Clearly, it's not the arithmetic. There's something else wrong. The numbers are correct, but there's something wrong. Something went wrong with this calculation. What is it? What went wrong? All right. It might not be very obvious because it's kind of subtle, but there was one condition in which you could do something like this. You could break up this calculation of the probability of N and T into the product of the probabilities if and only if what was true about these events. N and T are, anyone? Last chance? Independent, yes. These have to be independent events in order for us to calculate this as a product of probabilities. So what do you think? Is the event of being 6'3" or taller and being in the NBA, are those independent? Or is there a dependency? Does the NBA tend to have taller people? Yeah. Yeah. So those aren't independent. That's why this calculation is just so far wrong. It's because this assumes independence, but we don't have independence. Being tall and being in the NBA are related to each other. You don't have a lot of short people in the NBA. There used to be a guy named by the name of Spud Webb who was 5'6", but it's been years since he's been in the league. In any case, that's all I'm trying to get at is be careful. A lot of times people see this and they immediately jump to this. You can't unless you know for certain that these two events are independent. Comments or thoughts on that one? We okay? I hope that dramatizes the fact that, you know, you can't always do that. Here's a clear reason why.
It doesn't matter that T's uppercase and L lowercase.
No, I wasn't trying to trick everyone with uppercase and lowercase. Let's just fix that though. There you go. There we go. Now all is right with the world. Peace in the Middle East. Lamb and lion will be best friends. Good stuff. Thank you.